this calculating pHs and looking at hydroxide and hydronium ion concentration. Let's quickly get our words down. This is a, let's say this is equal to this, is equal to a proton. And here we call this the hydrogen ion. Here we have the hydronium ion. And OH minus is our hydroxide ion. They can be confusing, so you need to memorize them now. Hydronium, H3O plus, hydroxide, OH minus. All right, so based on the ion product of water, which is an equilibrium constant, we can say that the concentration of hydroxide times the concentration of hydronium is equal to 1 times 10 to the minus 14. Based on that information, we get this wonderful schematic in the middle of your screen. So if we wanted to know hydrogen ion concentration versus hydronium ion concentration, you will use either of these two equations. The hydroxide ion concentration is equal to 1 times 10 to the minus 14 over the hydrogen ion concentration. We get that from this equation over here. And remember, hydrogen ion is the same as hydronium ion. If we would like to go in reverse and we want to know if we're given the hydroxide ion and we wanted to know what the hydrogen ion concentration is, we will use this equation here. Okay? If we are given the pH of a solution, we can calculate the hydrogen ion concentration using this equation, where it's equal to 10 to the minus pH. And if we want to go in the reverse direction, if we're given the hydrogen ion concentration and we would like to find the pH, we will use this equation here, where the pH is equal to the negative log of the hydrogen ion concentration. Notice that we have the exact same equation on the opposite side. The only difference is we're looking at the pOH versus the OH minus concentration. What does that mean anyway? P is power of. The power of hydrogen tells us how strong is the hydrogen ion concentration. Power of OH tells us how strong is the hydroxide ion concentration. And if you remember, hydroxide ion concentration has to do with bases, and the hydrogen ion concentration has to do with acids. If we want to convert between the pH and the pOH, simply, we have one other equation, still based on the ion product of water, is where we have the pH plus the pOH is equal to 14. Okay? And it's all based on the original equation. I'm not going to go through it, but if you take a look at it, you can see how that works. So if I want to know the pOH from the pH, it's simply 14 minus the pH. If I want to know the pH from the pOH, it's simply 14 minus the pOH. Let's do some practice. Being that pH is a logarithmic scale, when you have simple concentrations like the first one, where we have 1 is our coefficient, and we have our power of 10, then we see here that we have 10 to the minus 6. Well, if we put that information in the calculator, where the pH is equal to the negative log of 10 to the minus 6. Essentially, the negative log just brings the exponents down, and we get the pH is 6. So what can you say when you have a simple coefficient 1.0 times 10 to the minus 6? Well, the pH is always, if it's an acid, is going to be that exponent without the sign. So if I was to say I had a solution that is 1.0 times 10 to the minus 9 molar HCl, then the pH would simply be 9. Okay? Let's try the next one. pH is always going to be equal to the negative log of the hydrogen ion concentration, which is negative log. And we know that this is the hydrogen ion concentration because we're looking at an acid. Okay? Negative log 5.0 times 10 to the minus 5 is going to be equal to 4.3. The next question is asking us for the pH, but we're looking at sodium hydroxide. So the information that we're actually given is the concentration of the hydroxide ion. Once again, like we did for letter A, we have this power of 10 is 3. So what we have here is the power of OH. So I can say that the POH is equal to 3. And to determine the pH is going to be 14 minus the POH. So we get 14 minus 3, and the pH is 11. Let's take a different approach in solving the next problem. Once again, we have a base. So the information that we're given is the hydroxide ion concentration. We can go from the hydroxide ion concentration to the hydrogen ion concentration, and from there to the pH. So based on our slide from before, our hydrogen ion concentration is going to be equal to 1 times 10 to the minus 14 divided by the OH minus concentration. So that's 1 times 10 to the minus 14 divided by 3.0 times 10 to the minus 2. What we get here is 3.33 times 10 to the minus 13. So we can say now the pH is equal to the negative log of 3.33 times 10 to the minus 13. And we get 12.48. Or if we go back to our original information that we were given, our coefficient has 2 significant figures. So we're actually going to leave those 2 decimal places. So when writing your pH, let's go back. When writing your pHs, you look at your coefficient for the concentration to determine how many decimal places you have. So at the top, for letter A, our coefficient has 2 significant figures, so our pH should have 2 decimal places. Since our coefficient has 2 significant figures, we need to have 2 decimal places in our pH. I put that back in my calculator, and the next digit is a 0. Okay? We have, for letter C, let's put our 1 decimal place because our coefficient had only 1 sig fig. Okay? So in the previous this slide, we did calculations to determine what the pH and the hydroxide ion concentration is, but what we didn't do is determine whether those solutions are acid or base. So we're going to do some more calculations and then determine whether we have an acid, a base, or a neutral solution. So the first question, a solution has a hydronium ion concentration of 1 times 10 to the minus 7 molar. What is its pH? And is this an acid, a base, or a neutral? Well, since our coefficient is 1, our pH is simply the power of 10. And we've got one significant figure in our coefficient, so we have one decimal place in our answer. Well, a pH of 7 is going to be neutral. So pH of 7, that's neutral. A pH that is less than 7 is acidic. And pH that's greater than 7 is basic. And we know that if it's neutral, the hydrogen ion concentration is equal to the hydronium ion concentration. If it's, I'm sorry, not the hydronium, hydroxide ion concentration. If it's acidic, the hydrogen ion concentration is greater than the hydroxide ion concentration. And if it's basic, the hydroxide ion concentration is greater than hydrogen ion concentration. Okay, let's try our second problem. What is the pH of a solution if the hydrogen ion concentration is equal to 7.2 times 10 to the minus 9? pH is equal to negative log 7.2 times 10 to the minus 9. Put that in our calculator, and I get 8.14, making sure I keep those last two digits because I've got 2 sig figs in my coefficient. If my pH is 8.4, going back over here to our definitions, do we have an acidic, a basic, or a neutral solution? It's greater than 7. So we have a base. Let us do the last one together, and then you can do the third one on your own and come back and check your answers. Okay, the last problem says if the pH of solution is 0.8, what is its hydronium ion and hydroxide ion concentrations? So given the pH, we can determine hydrogen ion concentration is going to be 10. It's going to be 10 to the minus 0.8. Plug that into your calculator and you get 0.16 molar. To determine the hydroxide ion concentration, we know that hydroxide ion is equal to 1 times 10 to the minus 14 divided by the hydronium ion, which is the same as the hydrogen ion. And that's going to be 1 times 10 to the minus 14 divided by 0.16 molar, and we end up getting 6.3 times 10 to the minus 14 molar. Is this solution a pH? Is this a solution an acidic or a basic solution? pH is really, really low, so this is an acid. Pause video, solve the last problem on your own, and we'll come back with the answer. Okay, to determine the pH, we are going to take the POH, convert No, we're going to take the hydroxide ion concentration, convert to the POH, and then convert to the pH. So the POH is equal to the negative log of 2.5 times 10 to the minus 4, because that's our hydroxide ion concentration. We get 3.60 because we've got 2 sig figs in our coefficient. So we have 2 decimal places. And then to determine the pH, that's just going to be 14 minus the POH, which gives us 10.4. So if we have a pH of 10.4, this is considered a base.